have the x-axis is here, here's my y-axis, and here's my z-axis. Okay? So my horizontal plane is xy, so everybody's desk is xy. And now what I want you to do is spin the top and try to get it so it's only spinning on the z-axis. So watch mine, and is this only spinning on the z-axis? You can't really see it. Can you see how it's only if it's spinning exactly on the z-axis? It's wobbling up and down, so it actually is spinning on some axis coming off in this direction. So Kyle got his to pretty much spin only in the z direction. There's an element, you see a component spinning off. So Jones and Haley, you're almost only in the z-axis too. And Andrews looks like it's pretty much in the z-axis. Yours is going into the z-axis. Paul's is leaning over. So you guys look here. If I have it spinning like this, it's only spinning in the z-axis, right? But if it's off kilter and it's spinning over here, there's a component of a spin in x, y, and z. Think of it in terms of forces. We want the force only to be in the z, right? We're getting a spin, we want a spin only in the z. But actually, it's spinning off of here. There's a component spinning in the x, y, and z. So that's what this physically is meaning. So let's take a look at this. On your sheet of paper here, what kind of moment did you get? Did you get a positive or a negative? A negative moment. So negative. If I put my finger in the positive x direction, that's the positive spin, right? But I got a negative, so which way should I put my thumb? In the negative. So it's spinning this way. So did I just here draw the spin correctly? It's a negative spin. I got MC to be negative 180I plus 36J minus 150K Newton meter. How about Y? Did I get a positive value for Y? Yeah, so stick your thumb in the positive Y direction, and the moment should be coming around like this. Is everybody comfortable? You need to be comfortable with these circles that I'm drawing. It's showing the spin. Go back to graphics. Because I don't see the back part of it, it means it's behind the axis, so it's spinning this way. Here, I don't see this back of this curved line because it's behind the axis, so it's spinning this way. Santiago.
Joanna, I don't really see how you're spinning about x and y. Can you show us? Because I think we're rotating from the C point. Is that right?
Yes, but we're looking, oh, that's a good point. Sorry, great. Okay. So x is fine, but we're looking at this y. Thank you, Santiago. This is the y we're looking at, right? Because we're trying to find a moment about C. Excellent. We're trying to calculate the moment about point C. So the spin that's occurring is here. Thank you. Thanks for correcting me. And on that same note, where is the z-axis?
Straight up.
It's also through C. Thanks, Cynthia.
So would that be a step for analyzing this? You move the axes, the origin to the...
Yeah, I think that would be a good point, because what happened is this y just confused me, right?
Yeah.
And I put the spin about here, but I was actually finding a moment about point C. So I think it is a good practice to move it, and then maybe cross these guys out, so don't get swayed by them. So Wes, we're up to you. What was the moment about point C and the Z?
Negative 150.
Negative 150. So how would I draw it up there? So put your thumb goes down, so it's spinning around like this, right? How does that look? Does that look right? So that's what I calculate in terms of the moment, and I want to make sure that you're comfortable with the physical feelings. So there's an element, there's a component of the moment in the X, there's a component in the Y, a component in the Z. How would I find out what the total moment is? So, Mark, oh, I already asked you a question. No, Wes, did I already ask you a question?
I
Before?
just did.
Okay, just now. So Mark, it's your turn. I might have skipped you before. Mark, how do I calculate what the total moment is about C?
I don't know.
Okay, so this represents what? The X component of the moment, right? This represents the Y component, and this represents the Z component. Whenever you get confused on what the answer is in terms of moments, think of it as a force, because they're both vectors. We are comfortable with forces. I totally know, and you totally have this feel that if I yank this monitor this way, you're going to know what kind of force it is, and you're going to be able to break it up into components. Think of moments the same exact way. Instead of a push or a pull, it's a spin, but it's still a vector. So if we know the X, the Y, and the Z components of the moment, how can I find the total moment? Mark?
You sum them up?
Yeah, do I add them? What do I have to do to them first? Because this is the X component, right? This is the Y. I basically want the resultant of that. Square them. So it's 180 squared plus 36 squared plus 150 squared under the radical, and it comes out to be 237 Newton meters. So it's a vector sum, right? And I think that if we had, Mark, if we had a force here, and I gave you the X, Y, and Z components of the force, and I said, what's the force? You would have had no problem doing this. You would have just squared the X, squared the Y, squared the Z, because we're so comfortable with forces. So whenever you get confused on a moment question, just make believe it's a force for a second. And you know how to find the result. So that means this force is creating what kind of motion? Jill P? What kind of motion is this force creating about this? What? A rotational, right? And it's 237. When I square these guys, we're getting a scalar value here. It has no plus or minus. It's just a scalar value. So if I go back to this, my top, I don't know where I put my top. Oh, here. If I take my top, I knew that, so everybody take your top and go on the x-axis and spin it in the way it's spinning. Go in the y-axis and spin it the way it's spinning. And go in the z-axis and spin it the way it's spinning. So it's spinning this way, it's spinning this way, and it's spinning this way. The sum total is a spin of 237 Newton meters. That's coming out of point C. Yeah, that's a, okay, so let's see. If it's spinning like this, so this is spinning like this, and this is spinning like this. They're both spinning they're both spinning in, and this one's spinning this way. Yeah, I don't really know because it's, I don't know, I can't figure it out visually. So let's look, X is 180. Y, let's look at the magnitude of the value. So it's spinning 180 this way, and it's spinning 36 this way, and it's spinning this way. Let me do that again. X is 180, it's spinning this way. Y is spinning this way, but only 36, so it's a little one. And then the Z is spinning this way of 150. So 150 like this, right? And like this, they're going to spin in the same direction it's spinning out like that.
So, can we use the right-hand rule on this?
Yes, and we're going to do that next. So I think that for you guys, well, no, I know you have no problem finding this force. Okay, You could probably do it in a minute. Okay? R vector, not a problem, it's just a distance. The math, no problem, you just plug it into your calculator. You pop out an answer and you might not know what it means, but it's important to understand what it means. And that's why we pulled out the tops and we looked at the spins about the axis. But otherwise, it's just a mathematical thing that spits out of your calculator. When we do it by right-hand rule, we're going to understand physically what's going on. Okay, so we're going to do it by right-hand rule now. Okay. Mark, do you have a question?
Yeah, I got a question. So, I was just thinking about one of the questions that was on the test yesterday, and
Okay.
if you have all your forces acting on the same point, if we had a couple different forces acting on that same point A there, that could cause rotational motion.
That's right. Right now, there's only one force that's going from A to B, right? But we could have had a ton of forces there. Picture a bicycle, right? Picture a bicycle. When you're riding a bicycle, you may think your weight's down, but when you're on that bike and you're moving like this, you're putting different forces on that same point, and you're causing different rotations. That's correct. So if we had more than one force, we would have to calculate the moment at point C due to all those forces. But, sure. What is the moment about point A due to that force? What is the moment on point A due to that force? Yeah, so look at where the force is. The force is going from A to B. Does a force going through point A cause a moment about point A? No, it's going right through it. So the only thing it could do to A is cause a translational force. It can't cause a moment. But this force is offset from point C, so it can create a moment about point C. Okay, so I'm going to make table. I like tables. So the first column is going to be force. The second column is going to be the moment about point C in the x, the moment about point C in the y, and the moment about point C in the z. And we have FABX, FABY, and FABZ. So let's just write what these values are. The units here is Newton. Then was Newton meter. Well, let's keep it millimeter now, just so that.
Is this the handout?
No, it's not. The handout is the second question. We're doing the same problem, we're just doing it by right-hand rule. So what was the force? 400. The 500 and negative 360. Let's put a row on the bottom that says total. Everybody has the table down? In order to do the right-hand rule, visually, I need to see what's going on. So the force is going from A to B. So at A, is the force going in the positive or the negative x? It's in the positive x. Force x, it's positive. going from A to B, is it in the positive or the negative y? Positive. Here's Fy. And how about in the z? Positive or negative? Negative. So does that sketch look clear to you? I have force x, force y, and force z. I drew them in the directions they're going. As you go from A to B, x is going in the positive. As you go from A to B, y is going in the positive. As you go from A to B, z is going in the negative. So Evan, looking at this table, what we're trying to do is, here's the force in the x, it's 400, it's going in the positive direction, right? It's going in the positive direction. And I'm trying to find the moment about point C. Remember I drew them already. Here's the z, here's the x, and here's the y. Does this force in the x create a zero moment about one of these axes? And we did this last week in class, last Thursday. Do you remember, Evan?
Yeah,
That's right. How come?
because that's the direction.
They're parallel. So this force in the x is parallel to x. So because it's parallel, there's a zero moment. Andrew, are there other zero moments in this table because their forces are parallel to the direction of the axes?
Force being force F.
Yes. So we looked at the force AB going in the x, and we know it does not create a moment about the x because the force and the moment are parallel to each other. So for force Y, where is there a zero moment?
I'm not seeing it.
Okay, David?
It's gonna be in the y.
Right. The force in the Y is going to be parallel to the Y axis through C, so the moment has to be zero. And